Good afternoon. My name is Stu Snydman, the Associate Director for Digital Strategy at the Stanford University Libraries and the leader of the Mirador project. And I'd like to talk to you briefly about IIIF viewers. As Sheila just showed you, the ecosystem of software for IIIF is vast and diverse. There are image servers, viewers, and more complex and sophisticated scholarly workspace applications. I will focus on two today, two of the more popular and well-adopted IIIF compatible viewers. The Universal Viewer, which has been adopted here at the University of Kyoto, and Mirador. Here is the popular tax map that my colleague Tom showed you earlier, shown in both the Universal Viewer and in Mirador. The Universal Viewer is called Universal because it can display many formats. It is capable of displaying simple images, books and manuscripts. It also has capabilities to display PDFs, audio, and video streaming from the web. Its book viewing capabilities are especially impressive, with the ability to navigate a book using thumbnails or other navigational controls, as well as view metadata and search within the book, allowing you to leap forward to search results zoomed in on the text that you found through your search. And while IIIF does not currently support 3D objects as part of the technical spec, the Universal Viewer has recently implemented support for rendering 3D models, some foreshadowing for what might be possible in the future for IIIF. The Universal Viewer has been adopted and is supported by scores of institutions from around the world and is being developed to evolve with the evolving IIIF specifications. Now I'll move on to Mirador. Mirador has three functions. Primarily, it is able to load content from institutions who are supporting IIIF around the world. It has the ability to view with deep zoom and pan, and it also has the ability to annotate content. But more than this, Mirador has become a very sophisticated scholarly workspace for comparison of content from around the world, annotation, and it has been used with many sophisticated use cases, from viewing and comparison to instructional and computational uses, as well as research and online exhibits. Mirador certainly excels at basic viewing of images, allowing the user to zoom deeply into the finest detail of color and texture. The major innovation of Mirador is the ability that distinguishes it from other viewers is the ability to compare images in the same workspace. So you can see here the ability to open multiple images of celestial maps, the first two from Stanford University, and zoom and pan and compare the details. You'll also see the ability to create a more sophisticated grid layout, such as this 2x2 grid layout, and to add content from other institutions. We'll see the ability to find a celestial map from the Bodleian collection at Oxford and drag the IIIF icon into the fourth window for comparison. Another important innovation of Mirador is the ability to annotate. Annotations can take any shape, and you can annotate regions on images with other images, text, audio, or video. Here is a rather sophisticated implementation of annotation offered by Harvard University for one of its cell biology courses, online courses. You can see when you hover over a region in the cell, descriptions of that part of the cell are displayed, and as you zoom more deeply, you can see annotations within other annotation regions. One of the more recently added capabilities of Mirador is the ability to display different layers of an image captured with different forms of photography. For example, this painting from the US National Gallery of Art was captured with traditional photography, X-ray, and infrared. The user can turn layers on and off, change their opacity to reveal important features. And I'm very happy to announce, with thanks to our friend Dr. Kiyanori Nagasaki, the ability that the Mirador now supports the ability to support right to left reading order in its thumbnail navigation and paging navigation. There's also a desktop version of Mirador that you can download onto your local machine, so you can try all of its features and functions with images that are on your local computer. Of course, if you want to compare your local images to images supported by IIIF on the web, you need a network connection. But this is a great way to test and experience Mirador. Mirador is a global project with worldwide participation, adoption, and contribution. You can see some of the institutions that have contributed to the development of Mirador, including the University of Tokyo. All told, the equivalent of 16 years of effort has been invested in developing Mirador, and we continue working. Currently, we are in version 2 of Mirador and are now planning the next version, version 3, which will improve the user interface, redesign the technology architecture, and add new features for customizability and extension. We'll take the lessons of the past 8 years of work on Mirador to make a great new version. So, we welcome your participation and your involvement. I know many people in the room have used Mirador, may have ideas. We're very interested in hearing your feedback to contribute to the next versions. You can go to the project website, contribute on GitHub, download Mirador Desktop, or join our email list. Now, I'll ask my colleague, Jack Reed, to come talk about another important Mirador tool, IIIF tool and viewer, Leaflet IIIF, and some sophisticated applications of IIIF.